Hi there, this is session 16 of programming from the very basics using Python. In this session, we'll learn how to get started with strings. I'll tell you how to get working with strings, the very basics in this session. This will be a multi-part tutorial. So in this session, I'll talk about the very basics, the absolute basics of creating a string, different literal notations, and basic string operators is what the focus in this possibly 1 hour session. So we already seen how to create strings by using literal notation. We have learned how to create a string by using a is equal to hello world like this, right? So if you want to create a string, you can always start with quotes and you can put any characters inside them, any Unicode characters, and you can close them with the matching quotes. Well, the literal notation of string has different ways of quoting, and it's there for convenience. In order for me to demonstrate that, I have to switch back to my terminal, unfortunately, because one of the problems I always keep facing is that when I try to open quotes, the close quotes created, sometimes I have to go back and delete it, and then it gets created again. It's a little bit of a fight with this IntelliSense in VS Code, and it also happens in the plain Jupyter Notebook too. So what I'm going to do now is I'm going to go with the Python shell at this moment, explain the literal notation, then come back to the Jupyter Notebook for maintaining the trails. So let me start by launching Python first. Let me just increase this font size a bit. Yes. I'm just going to use the plain old Python shell, not IPython. You can also use IPython if you prefer, but it's all the same. One of the ways to create a string is by using, s is equal to, I could just type open double quotes, right? And I'll just type maybe I will be back. I'm there, but yeah, this is just a dialogue in a movie called The Terminator, right? But is it I will be back? No, it says I'll be back. Anyways, so when I try to print it, obviously you can just see that the type of string, a type of S is a string, of course. This is one of the ways to create a string. But you can also create a string using single quotes. Some people prefer using single quotes because one of the challenges with double quotes, many people tell me is, you gotta hold the shift key and press it, right? On most of your standard keyboards, is like shift quotes, shift quotes. Yeah, it's painful. This finger hurts holding shift all the time, right? The shift key syndrome. But if you're a person who don't like pressing shift all the time, no problem. You can always use single quotes like this and still say, I will be back. And this still works. Absolutely no difference. Either you can create a string represented with double quotes, or you can create a string represented with single quotes. Whatever quotes you start, you match with that quotes at the end. That's what really matters. The reason why they have provided these two possible ways to create a string is obviously for convenience, and also another aspect I should tell you. Suppose if I have a string that's got quotes already inside it. Let's assume that I'm going to type it like this. I'll be back, which was the actual dialogue in the movie The Terminator by Arnold Schwarzenegger. How you pronounce his name? I don't know. I couldn't get it right. But anyways, Schwarzenegger. Okay, whatever. Fine. So if I just run this, it throws a syntax error. And you know why? Because you open the quotes here and you close the quotes right here. That's what Python sees it as. It does not understand that this is an English apostrophe, and it doesn't understand that. So it throws a syntax error. If you want to fix it, one of the ways to do that is by escaping all the quotes within a single quoted string with a backslash. Like this. So if you want to represent a single quote as is within a single quoted string, you got to backslash all the single quotes within that string. Right? So if you just print S now, it works. It's like trying to tell Python run Python grammar, the syntax grammar checker, for example, telling the parser, for example, to ignore these quotes. Treat the quotes as is. Don't apply any special meaning to it. Just treat the quotes as quotes. Don't assume it's the end of string sequence, right? So it does that accordingly with the aid of this backslash. It's also called as a backslash escape. Escape any special meaning that can be implied to the next character by the Python parser, right? Of course, the backslash added before certain characters will add meaning to it. We also call them as the C style backslash escape sequences, which I will talk about in a while from now. Now, suppose if at all I have a lot of quotes which are single quotes within a string, a lot of single quotes inside a string, it could be more convenient to wrap the string within double quotes. In such case, you don't have to backslash escape any single quotes inside the string. It is just a convenience. The converse is also true. For example, if at all the dialogue was, he said, I will be back. And that's not he, I'll say, Arnold said, I will be back. As we watch the movie, whatever it may be, otherwise we watched. And when you press enter this time, you get the same error. You can see, because you open double quotes here, you close it right here. Anything after that is an invalid syntax by the Python parser. So if you want to represent double quotes inside a double quoted string, you need to backslash escape the double quotes inside as well. But instead, you could have enclosed a string within single quotes. And now you don't have to backslash escape the inner double quotes. This is the convenience. But now some of you might say, ask rather, what if there are both single quotes and double quotes inside a string? Well, let's try. This is going to fail. Now, what do I use now? I can't enclose in double quotes. If I enclose in double quotes, I have to backslash escape the double quotes inside. If I enclose in single quotes, I have to backslash escape single quotes inside. But you know what? Python can still save you. You can always represent this string in triple quotes. Triple quotes. The triple quotes can be represented as 3 single quotes together. So what you start here, triple quotes, you can end with triple quotes. This way, all the other quotes can be left as is without needing backslash escape to them. It works. And now even ask me, what if there are 3 triple quotes inside the string too? Well, you can enclose this in 3 double quotes. So triple quoted strings can either be represented as 3 double quotes and with 3 double quotes. We call it double quotes, right? So 3 of them. Or you can use 3 single quotes based on your requirement. And all this works. Now don't ask me how do I escape this one. That's it. It ends here. It ends here. Okay. You better make up your mind. So if you just try to print S so far, it works. The triple quoted strings also provide another benefit. And from now on, I've switched to the Jupyter Notebook, right? So I told you we can represent string in single quotes or double quotes. And I'm going to put these lines, which are all valid. The valid ones, I'm just going to copy them there. Which one was it? Hang on. This seems valid. I'm just going to copy that part. Paste it up right here. Maybe you'll call it A. It doesn't matter. Oh, this was not valid. You can see it throws an error. So you need to, because, this won't work because I need to put them in triple quotes, of course, in this case, right? Or you can use this one. This is perfectly valid. All of the different ways you can represent strings with quotes. All of these create a string object. All of these are literal representation of a string. Literally, I'm just typing the string. So the parser will figure out, oh, you're starting with quotes. Everything inside it is a string. So it'll create a string object, store them as values in a string. That's what it does, right? So these are the ways to use a string. But one of the challenges is if you have a string with a lot of backslashes inside them, and I will tell you a specific use case. If you work on Windows, for a strange reason, Windows treats path separators with backslash. It's not Windows, it's actually the days of MS-DOS. I've been a DOS user in the 90s time frame, more of a DOS user. So I know that backslashes were the norm in DOS for separating paths, right? Separating folders in path. But that's a problem. I'll tell you why. Imagine that I'm trying to write some kind of a Windows installer in Python to install some software. And I have a variable. Let's call this install path is equal to, and I'm going to install software in a particular location. Let's say C colon slash, maybe I want to store it in new folder slash temp slash backup slash network slash remote slash test slash what else I can think of. Well. Yeah, I think I sorted. Let's see. There's a path I know represented where I want to install the software. Some deep down path, let's assume. Sorry about this. Bad throat again. So try to print install path at this moment. You'll be surprised to see the output. It looks, wow, I got a telephone here. Interesting. If I try this on the terminal, you get a bell, you get a ASCII bell, it's called. You'll get a beep sound if you have a PC speaker available. I don't see that happening these days though. What really happened here is this. The slash in is treated as a new line. This is a relic of C programming language. I'll not say relic, it's a feature. In most popular languages today, derived sort of from C. I guess C got it from BCPL or some other language like that, APL or BCPL. Anyways, came from that lineage. So slash n is an escape sequence to represent a new line as a character. Actually, when you press enter key in your keyboard, the enter or the return key on your keyboard, it actually generates a character. The ASCII value for the character. On a PC class keyboard, it generates two characters. There are two character sequences generated. One is a carriage return, the other one is a new line. I think it comes in first new line. Okay, it's actually CRLF, yeah. Carriage return and then new line. Yes, that's correct. CRLF, called it. Sometimes some of the platforms, I think it's some very old versions of macOS used to have the opposite of it. It's a new line carriage return sequence anyways. But the old Unix keyboards working on Unix used to generate a single character, which is new line. New line implied a carriage return perhaps in the operating system perhaps. So anyways, all those are the relics of the 70s and 80s generation. But it's still there today. We still use the same keyboard for writing code. What existed from the 1970s, right? Just improvise the colors and so on. That's it. But it's all following the same concept. So have you ever figured out what's the use of a scroll lock key on your keyboard? Is there still on my keyboard? I can find a scroll lock. Relics of the 80s, right? We don't use it anymore, but it's still there. Maybe you have a program that requires it. We don't know. Yeah. So you can see that slash n is new line. Slash t is an escape sequence for the tab character. That's a character that you get when you press a tab key on your keyboard. If you want to represent the tab character in a program, literally, you put a slash t in a string. It's all coming from C language, right? It's all being borrowed from there, right? So it's not unique to Python. It's the case with many languages, right? Slash n is new line, slash t is tab character, slash b is actually a backspace. A backspace key also generates a character, which is a backspace character. And slash n, slash r is carriage return, slash t is tab character, slash a is supposed to beep on the PC speaker, but these days I don't think that's being done. I think it puts a telephone sign there. It's ignored, but some old machines you'll see a beep sound when you use a slash a. It's called as ASCII bell character. So you'll see all these characters are represented. That means that backslash added special meaning to the next character following it. So if you don't want this to happen, the complicated way to make this work is painfully escaping every backslash like this. A backslash before another backslash tells the Python parser not to apply special meaning to the backslash itself. Backslash escaping the backslash. Wow. It's a mouthful. So you can run this now. You get it as you see here. It's very inconvenient to do this. So Python has an interesting trick. What you can do instead is use a special operator called as rstring, also called as raw literal string notation. So the moment you use this, it's called as rstrings, aka raw literal string notation. Before any quotes, you put a small r followed by either single quotes, double quotes, triple quotes, whichever quotes you want. Make sure you enclose with the same quotes, right? The string is treated as is. How does Python do it? Well, this R character, what it does, that's an operator. It's a string literal operator. Before constructing the string, it's going to replace every backslash with double backslash on my behalf and then create a string. That's what it does. That's the way it is, right? So you run this now, it works. In fact, if you want to get the, if you want to tell the, if you want to ask the REPL to show how the string is represented, you can just put install path here and you can see that all of them are escaped. See this? All backslash and double backslash. Though I use single backslash here, you can see the R did the magic. See a backslash, put another backslash before it. See another backslash, put a backslash before it. Then try to construct a string object. Let it parse and create a string object after that. This is called as R strings. So if you want to represent raw strings, this is how you do it. The place where you'll use it even today is one place, regular expressions. In a regular expression, /b stands for word boundary. /b is a word boundary, \b. But then if you want to use a word boundary semantics in a regular expression grammar, unfortunately you need to backslash escape that \b because /b here is backspace. You don't want the Python parser to first change it to backspace. I want the regular expression engine to see that as /b itself. So if you're trying to represent regular expressions, you might ask me what are regular expressions? For those of you who are not aware, this is one of these super magical features in programming to do wonderful things with string processing. If all you want to do things like matching patterns in a string, extracting parts of a string based on a pattern, or doing some substitutions based on a pattern, regular expression is the key to do it. I think I'll be covering regular expressions in the next couple of sessions from now. I think this is part 1. So I think we'll have a part 2, then part 3 perhaps. I'll be covering regular expressions. So hang in there. It's a very useful feature. So it'll give you superhuman capabilities once you know how to use regular expressions. And yes, regex is used even in places like data analytics for in the initial part of it, pre-processing data. If you're dealing with strings, sometimes you need to use regex to clean up data. It's all used there, right? Let's get with this now. I talked about how you can create strings literally by using single quotes, double quotes, triple quotes, and I also told you about drawstring. Coming back to triple quoted string, it's mainly used for another purpose, representing multi-line strings. If you want to represent a string that spans beyond one line, let's say 3 line, 4 line, a paragraph, you can't do that with single quotes or double quotes. If I try to say this A is equal to this is a test and continue the next line and put something else and put something else, you can see that the VS Code is highlighted this. It's an error. So if you want to represent a string that spans more than one line, which is a paragraph, you can represent the string easily with triple quotes. You start with triple quotes, end with it. Whether you want to use 3 double quotes or 3 single quotes is up to you. It's available as flexibility. But my suggestion, whichever format you use that consistently throughout in your program. Don't mix them. If you like to use single quoted strings all over the place, use single quotes. But for multi-line strings, you want to use triple quoted strings. Whatever triple quotes you plan to use first, follow that through in a program. Make sure your program looks consistent. One time use 3 single quotes, another time use 3 double quotes. It can look a little, inconsistent and not very clean. So always follow this clean coding practices. And now when you run this, it has no problem. In fact, when you try to print this, it retains that formatting as well. So when you print it, it shows up in 3 lines. This is very, very useful if you're building some programs in Python that involve representing strings that are quite long, which are maybe SQL queries as an example. A typical SQL query is a quite long query. If you're going to be communicating to SQL compliant databases, RDBMSs of the yesterday era, see when used today, MySQL or MariaDB or PostgreSQL, even SQLite, they allow you to run queries which are like English-like, quite long though. So sometimes you might want to say maybe, I could just call this as SQL is equal to create table users. And I want to continue the next line. So what I'm going to do, I'm going to nicely format it. I can just say create table users and open parenthesis here. And below inside this, I can just use things like say ID and I can just say integer primary key. Yeah, by the way, I'm following the sort of remember the SQLite's query syntax. I'm using it. Oh, I do know databases. I do trains on databases, right? And so name, I could use varchar of 32, not null. And maybe I'll say unique, putting a lot of keywords. Let's say maybe role, varchar of 32, and not null, and department across DPT, varchar of 32. So this is some kind of a SQL kind of a query. It's nicely formatted in multiple lines. Doing this in many other languages involves create one line with string like create table users, close quotes, plus next line, plus next line, plus. You could do a lot of concatenation. Or if you're a C program, it'll put a lot of backslash escapes at the end and messy, right? But this is how you do it in Python. So where you want to represent multi-line strings, nicely formatted. Or it could also mean HTML snippets. You want to represent a snippet of HTML or maybe XML. I'll use HTML here. I'll say HTML header is equal to, I could also use triple quote string. This time I'm going to use 3 single quotes just to show you that both work just fine. So I can start off with maybe doc type HTML and start with HTML semantics, maybe a head tag, and maybe it has a title tag and say a sample web page, sample report, title tag, and close a head tag, and maybe start the body tag. Maybe this confirms the header. Maybe I can add a footer, I can put some body and other things. It doesn't matter. I'm just trying to show you, you can represent multi-line strings easily, maintaining that format, the line format, by using triple quoted strings. There's another place where triple quoted strings are used extensively in Python is for documentation. We also call them as doc strings. What does it mean? Yeah, it's a little bit of a digression, maybe looking like a detour, but it falls in place. Okay, let me tell you. If I'm going to define, if I create a module, and if I want to tell my user what this module is all about, I can add a module level documentation. So I'm going to show you places where you can put documentation in your code. Let me create a new file here and call this file as, okay, Python file. And I'll save this file first. I'll save it as some interesting name. Let's call this as mathutil. mathutil.py. Maybe I create my own module with some small mathematical utilities. Maybe I want to create a function to generate Fibonacci series, or I want to write a function to find a number is a prime number or not, or generate prime numbers. We did all these exercises some time back, 2 sessions ago, right? You can put them all in one single module, and you want to write a nice documentation for it. And the way you do that, the first line or the first statement in your .py file could be a documentation like this. You could actually use a single quoted string if it's a one-line documentation, but it's very common that you have a paragraph word documentation. That's why I use triple quoted strings. So you could just use mathutil. You can just say provides useful utility. Let's say math utility functions. And you can say maybe a separate, put a blank line, and then you can say this module provides functions to find GCD. We wrote that. Find GCD, generate Fibonacci. And this formatting is not required here. You can say Fibonacci series, check for prime numbers, and so on. Whatever. You can put any kind of detailed documentation. It's up to you, right? Telling what the module does. This will be the first statement in your program. You should not have any other statements before it. First statement in your .py file to be this. After which you could have any definitions. Maybe I want to define a function here to generate Fibonacci numbers. So this Fibonacci numbers will take an argument. It's a function. The first statement, even inside a function body, can be a docstring. So I can use a docstring here. Generate Fibonacci series. Generate the first n Fibonacci series, whatever n is passed as an argument. It's a one-liner, so you can have a single quote strings, but it's generally customary to use triple quote strings because maybe you want to elaborate the documentation in the later time. It's always suggested use triple quote strings for representing documentation, right? And then as usual, you can actually do this. You can just say a comma b is equal to 0 comma 1, and we could just say for I in range of n. So I'm going to show you another interesting thing. I forgot to mention this when I actually talked about that in the for loop. This loop variable that is there, I want this to count n number of times. But whatever that value is I, we are not using it in our code. What we did here, we used to print a and put n is equal to space, let's assume. And then we did a comma b is equal to b comma a plus b, right? This is what a Fibonacci generator used to do. But then we never use this variable called I anywhere inside. But we need this for loop so that it runs 10 times or 20 times. But that number, that counting number, we don't need it in our code. We just want to execute this block this many number of times. That's it. So when you have a use case scenario where this loop variable is not going to be used, it is not a rule. It is a common practice to use an underscore here. Underscore is a valid variable name in Python, but you should not create useful variables with the name underscore. Underscore is like a don't care variable. This is a variable that's just there to satisfy the syntax grammar rules, because for expects a variable to be passed as one of the argument, but I'm not going to use a variable. So I'm going to say don't care variable underscore. I'm not going to use it, right? So it's just a placeholder variable. You can use that. You'll see this kind of code very commonly in Python. And you can have another function, let's say def and maybe HCF. We created HCF of x comma y. We wrote it as a program. We can make it a function here, and that's pretty straightforward. I think you could just say while y, x comma y is equal to y comma x percentage y, and then ultimately return x. But we can write a nice documentation here. We can just say returns the HCF of x and y passed as arguments. That's it. So the first statement inside a function body, the first statement inside a module, there's a module. I told you any file with .py is a module, just in the previous session, right? So know that. And the first statement inside a class definition also can be documentation like this. It's a docstring. What happens when you do this? This acts like sort of comments, but it's not really comments. Yeah, it does play the role like comments. It sort of tells us what it does, but it's not something that's ignored by the Python parser. It creates a string. All these will be created as string objects. Remember, triple quoted strings, string objects are created. The string objects which are created in the beginning of the function definition, beginning of the module definition, or beginning of the class definition, they are represented as a documentation for the function, the module, or the class. Now, once you save this file, I'll save it. I'll go to the Python prompt here, in here. I'm not in the Python prompt. I'll just type import mathutil. I'll go to the module. I can now use help of mathutil. Wow. We saw help here. And you know where this help comes from? These docstrings. So the first line becomes a synopsis, which you see here. Oh, that this was redundant. I shouldn't have put this. Anyway, put that module name hyphen there, right? Mathutil And what I type math came out. So sorry. So you can just remove that. Okay. Provides useful math utility routines. After one line blank, whatever you put in goes into description, and all the functions are also documented right in here. It's pretty straightforward. Not only here, if you go back into your Jupyter notebook and try to use import mathutil and load this module in another cell. If you just type mathutil dot, if I just type, see, it tries to autocomplete automatically because figure out all the members of a module. The moment I say Fibonacci, open parenthesis, do you see that? The help. Generate the first n Fibonacci series comes from the documentation that I wrote there. And this is how most of your built-in libraries are documented, right? Just so you know that doc strings, when I use the word doc strings, documentation strings are shortly called as doc strings. Doc strings are nothing but triple quoted strings placed strategically in your code, the beginning of your module, the first statement in a module, or as a first statement in a function body, or a first statement in a class body. That's what it means. And that's the common use case in Python, apart from representing other arbitrary multi-line strings here. So all of these are standard literal notations of strings. There is another literal notation which I talked about, which does not create a string object. If you remember, I told you when I say A is equal to B quotes like this, what does it do? This creates not a string object, but creates a bytes object. And I already told you what a bytes object is, right? You can see this. When I talk about file IO or file IO mainly, that's where I'll cover this even more. Mostly when I talk about dealing with binary files, we'll go one more layer deep into managing binary data. Right? So you can see that right here. So when you use a B coded string, this creates a bytes object. And the next thing I should talk about is a very interesting one, which originated from Python 3.6 onwards. And these are the most popular F strings, also known as format literal strings, string syntax or string notation. People simply call it as format literal string syntax. I cautiously avoided having to use this notation carefully when I was using print statements all along because I had to cover this, right? I had to cover this. I thought I could cover it in the earlier sessions, but I thought it's too early. So once you know some bit and pieces of Python ingredients, it makes sense to enjoy this feature, learn this feature and learn how to use it. What is this all about? Let's assume I have a variable here. Let's say user is equal to John, score is equal to, let's say 45. If at all I want to print a message, I want to represent a message, I can say player John scored 45. I want to say player John scored 45. You know, if you want to use a print, we used to do this so far, right? Remember in the previous sessions when I talked about for loop and for iteration helpers, I talked use zip and, you know, I put welcome, I said hello, comma, the variable, comma, again quotes, welcome. Multiple strings were passed as parameters, pretty much like this, right? Player, user, scored, score. But you know what? I'm passing multiple arguments to print here. But I can actually formulate into a single string, which is very, very convenient, which I'll show you. This is not F string in here. No, just put this here. This time, I can use an F string with print like this. This is not a print feature, it's a string, okay? I can say F string, like it's a player, open curly brace, close curly brace, open curly brace, here also, close curly brace here. It's a single string. Well, it's not a feature of print. You can actually formulate this as a string like this. I'll just copy this cell one more time. This time what I'll do, let's say message is equal to, or the MSG is a short name I'm using for message, is equal to player name. Instead of calling it user, let me call it as player here. and score. Score. If you print message, you don't get anything. But now for the string, just put a small f here. Put a small f followed by quotes within the string. Whenever there are curly braces, whatever is within the curly braces, that is treated as a Python expression. It is evaluated, and the result of that expression is represented as string in place. So user is a literal user is an identifier. An identifier can be used as an expression. I told you, right? So the identifiers will result to John, and John will substitute that location. So you can use any Python expressions in here. Even things like this, you can actually do this. You can say f string 10 plus 20 equals 10 plus 20. Maybe we learned in mathematics like this, but in programming, it's always like left hand side equals right hand side, right? So we say 10 plus 20 gives me 30, right? You can do something like so. It's a valid expression here. You can put any Python expressions. The expression is evaluated, and the outcome of that expression is represented in place as a string. You'll call str of that result, right? I told you can represent any object as a string in Python, and the string representation what is substituted in here. This is called as format little strings, which means you can substitute variables easily within a string using curly braces. There are many languages which have this kind of weird syntaxes, like say Perl and Shell dollar signs. Right? You say dollar variable in those languages, even PHP for that matter. In some languages, you use more weird syntaxes. I think Ruby had this feature a long time ago. I think we would have hash curly brace, but Python got this inspiration from languages like perhaps Ruby, perhaps, right? So you can see that. So, and yes, one of the things I can also show you is that you can support a lot of formatting operations here. It's called as format little string. I'll show you another example here. Let's try with a couple of players here. Players is equal to, let's think of names here. Let's say Adrian and Steve, and say Jan, let's say Lisa, and say it's a long name I can think of. All right. Okay, Damien. Oh, my name is very long. Let me put my name there. Okay, very outlier name. Okay, Indian name with all these. Doesn't matter. Scores is equal to, let's say the scores are all in floating point with a lot of digits in it. Sometimes the score could have very large numbers too. Yeah, I think that's enough. How many are there? 1, 2, 3, 4, 5, 6 names. 1, 2, 3, 4, 5. One more score I will add. Make them equal, right? You can, it'll work even then, but, and I think you would have guessed what I'm going to do next. For p comma s in zip of, zip of players comma scores, I'm going to print f string. I'll just say player p, put p in curly braces. Oh, sorry, p in curly braces, score s in curly braces. You got the output, but it doesn't look very readable, isn't it? Let me try to format it now. Nicely formatted. What I'm going to do now is I'm going to copy this cell. I'll show you how it is as is. And here I can say P colon, and I can just say maybe format it to 15 characters. 15 character string. Let's say 15. 15 will do, I guess. Yeah. You can see that? Nicely formatted. And score, I want to format it's a number, so I want to format it right justified. Strings, I want to left justified, that's the default. If it's a number, I can right justified. I'll say S colon, and I want to make it right justified to how many it is. Let's say Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's use 12 for to be safe. Nicely formatted. But it's still not very clean because the decimal points are all over the place, right? Because of the decimal signs. I want to just make sure that I want to round off the decimal points to only one decimal point or maybe two. So I can do that. So I can actually say 12.2f. 12.2f. Uh, if you come from C programming background, this is reminiscent of the printf style formatting sequence. Printf format, right? Percentage %d, percentage %f, percentage %s. It's sort of similar to that. Even here, I could have put a s here, but that s is not really compulsory because it figured out it's a string object anyway, so it'll be string formatted. But all these are like the padding that you can do. So with this kind of formatting, you can actually nicely put it in a table if you want. One more level of improvisation is obviously you can do this. Before you start the for loop, let's say I'm going to print of, I put a plus sign and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Let's put a 16 there. Plus. Oh, before I do that, I also need another plus sign. So player counts as 1, 2, 3, 4, 5, 6, 7. 7 characters. All right. Let's use 1, 2, 3, 4, 5, 6, 7. Let's use 8 and 9. So to give some spaces surrounding it. Followed by 15 characters. Followed by 12 characters. Oh, no. Score is like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me give 9 characters here. And then I'll add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe I'll use 14. All right. And add a plus sign here. And then in here, I'll just make it as player. Put some spacing. I'll put a pipe symbol. Player. Followed by a pipe symbol. Hopefully this works out fine. And a pipe symbol here. Score. A pipe symbol here. And I can use a pipe symbol here. And in the end, yeah, it requires a little bit of experimentation, but we'll get it to work. Sort of off, but maybe I just need to add another space for player here. I think that'll fix a bit. And maybe I had one more hyphen here. One more hyphen here. Let's fix a little more. And for score, I need to reduce certain, I think, 2 characters. 1, 2. 1, 2. Nice. We have a nice tabular data, right? And if you want to do this, you need to do this padding correctly. So you need to have this padding with spaces correctly and all these, right? This is what format literal strings are all about, right? It lets you format your strings the way you want with a lot of flexibility. Unfortunately, in this, though I will be covering format strings, I will not go in one go and cover all the nuances. The more I cover, the more easily you'll forget. So I'm covering the basic things, but when you have time, go and play around. There are a lot of options that are there. Some more things I will show you, and I will show you the options finally. Maybe sometimes I want this name to be not left justified, but right justified. I can also do that. All I need to do is after the variable colon, I can actually use greater than for right justify. You see that? The names are now right justified. If I use the default is like telling less than, which is left justified. If you don't mention that too, for strings or by default left justified, but maybe I want to center justified, I can put a cap symbol. It's like less than is left, cap symbol is center justify, and greater than is right justify. And you can see this. It gives you a lot of flexibility in here, how you want to format your strings. So these are one kind of formatting where you can use this kind of spacing and padding and justification and so on. There's another feature that format little strings provides is type conversion, which is not with this example. I'll show you another one. Let's say that I have a number here. I say a is equal to 1, 2, 3, 4. If I just use f string of a, it just represents 1, 2, 3, 4 as is, as a part of the string. So this is actually a quick hack to convert an integer to a string. You can see that this is a string because string is created with the integer value substituted inside the string. This is like calling str of a, right? But I can also do this. I can just say a colon b. You know what this becomes? That b stands for convert to binary literal string format. You could have done that with bin function. I told you about bin, oct, and hex. I hope you remember. Right? So it's there in the very early sessions. So I told you that there's a built-in function called bin, which when you pass a number, an integer number, it creates a string representation, but in binary, right? But you can do that with format string with this kind of sequence without having to use that function directly. I could also use a colon x to get hexadecimal, a colon o to get octal notation. It won't add the prefix, however. It won't add the prefix. If you don't add the prefix, I think you can always add 0b like this and 0x here, and maybe you can put 0o here. I guess there's a way to add that automatically, but I don't know the complete depth of string formatting. When I need it, I'll go and look up the documentation. But I just scratched the surface of what you can do with string format operation. But how do you learn more when you have time and when you need certain specific use case? Here's how we find out. Obviously, the documentation. So you'll open up the documentation right here. It opened up. Just go to docs.python.org in your favorite web browser. So if you go to the Python documentation, you can go to the library reference for now. When you go to library reference, within the built-in types, there is a chapter on string. Is it covered here? No, it's not in that built-in types. Scroll a little down in the library reference. You will see a section called text processing services. And below you can see that string, common string operations. Click on this chapter, on this section rather. You click on this section. It shows string, common string operations. Earlier they had a nice hyperlink to hop inside, bookmark it, but now we have to scroll down. I'll tell you where to scroll, so you can see this. Custom string formatting. Earlier, this whole format operation I talked about was part of a method, string method called string.format method before Python 3.6. In 3.6, they made it as a literal syntax as an option. You can still use a string.format method when you talk about string methods in the third series of this session, right? Third series of this string operations series. I will talk about all the methods. So, but when you go further down, I think somewhere, yes, here's where it's documented. Look up this section called format string syntax. This gives you the complete syntax grammar for it. That means format string syntax is all about curly braces followed by field name. Everything in square bracket are like optional, right? Either it's field name, you can have an open square bracket, exclamation conversion, or you can say colon format specification. So what I've covered so far is format specification, not conversion, right? But if you want to look at format spec, it's covered below here. Format spec has this. Click on this link. It tells you everything that you need to know about format specification. You can put the fill, align, sign, z, hash, zero, width. Wow, way too many things. When you look at this at this moment, it might look a little too overwhelming. It's overwhelming for me. Yeah, it's not that you want to memorize all these things, but you should know where the documentation is. So when you need something to be done, you go here and check it up. So I talked about all these justification, right? Left justify, right justify. You can also put equal to if you want to put leading zeros for digits, And you can see this over here, sign option, and all of these are types. I showed you only B and D, and no, I didn't show D. I said I should B. By B for binary, O for octal, X for hexadecimal. Oh yeah, if you want the 0x to be automatic, I just thought it should be there built in. If you want a small x, you have to put the 0x there, right? It just puts in, see, if you put a small x, you get this like this. But if you want that 0x prefix, put a capital X here. Oh, sorry. I thought that's what it is. Oh, you need to put a hash, I guess. Oh, you need to put a hash. Maybe a hash X. Yeah. Well, capital X will put in capital letters, small x in small letters. That's the difference. You can also put a hash over here instead of putting this hard-coded 0. Or you can also put hash B here. To be honest, these are things which I'll learn and I forget it because we don't use it. Okay, that's the whole point. So it's not that you have to memorize all these things. These are very low-level intricate details which you can always get from the documentation, right? This very lookup. And there are examples to show you how you can format format string literals and everything. So it's all covered in here. Have a look. So they show you all the different forms to use it, right? So this is another literal syntax for representing a string. That is the F strings, right? Now that we covered all the string notations and syntaxes, now let's talk about certain string operators. What are the operators that string supports? Well, there are these operators. So I can say A is equal to John, and let's say B is equal to Doe. I can say C is equal to A plus B, and I guess you know what you get as an outcome, John Doe. This is string concatenation. You'll realize after a while, maybe in a couple of sessions after the string, I'll be covering tuple, list. You'll see these things are common in all sequenced collections. Every sequences support concatenation. And there's another one which is also a common sequence operation, which is string repetition. Suppose you try to say print C into 5. Or why would you repeat a string like this? Maybe you want to print a string multiple times. One use case is here. You see this, I put all these things manually. If you really know programmatically you want to count how many characters are there, you can actually use a string repetition operator. Let me show you one example here, a simpler one. Maybe I want to print some header in ASCII. I could just use this. I could say print, I can use equal to into 40, print space into 15, followed by hello world, and then print hyphen into 40. You want to do formatting like this, you can use the repetition operator. This is called a string repetition. That means one of the operand must be a string, another operand must be an integer, not a float, should be an integer. You can't say repeat a string one and a half times. It doesn't make sense. Try it out. You'll throw a type error. Okay. So it'll work only with integral operand as the other operand when you use this. So string into integer will basically repeat a string that many number of times. Right. This is one thing that you should know about. This is called string repetition operator. And the next one I should talk about is the square brackets, which is the subscript operator. So when I have a string here, let's say if I print C of 0, J, it prints J, right? So I'll take another string here. I'll just take a string that looks like this. I'll just say S is equal to, this is a test string, simple string. If I print S of 0, will extract the first character. It gets you an item from the sequence. In this case, the item in a sequence is a character. Gets the first character at that index. You try maybe S of 5, you get the fifth character. I think if you start counting, the 0, 1, 2, 3, 4, the fifth character is this I that is there here. The I before S, right? In this is. So it extracts that. So you get T followed by space followed by that I there. If you want to get the last character, you can also try S of -1, but you can try S of -5, for instance. This is S of -1, G. That's the last character. S of minus 5 would be this t. If you start counting from here, it is minus 1, minus 2, minus 3, minus 4. The t is minus 5. So it prints t there. So you can actually extract from right to left by using negative indices starting from minus 1, left to right by starting positive indices starting from 0. And as you can also, as you already would have known, that if I try to do something like, say, s of 20, it would, oh, 20 works. Okay. It's longer than that, I guess. I try 30. You get this error. If you provide an index that's beyond the length of a sequence, you'll get an error, which is an index error, right? So something that you should watch out for. How do you know what is the size of the string? What do you think the answer is? Remember, len function. All collections, all collections. Oh, it won't work here because obviously it's through an error. So I'll show it in the, I'll copy it in the next cell here and remove this. You can always find out the length of any collection, including a string, by using the len function. Len of any argument, the argument must be a collection, not an iterable, it must be a collection. There are certain iterables which are not collections, which I'll discuss much later. Okay, so you can iterate over them, you can iterate over them using a for loop, but they will not tell you how long they are, how many elements are there beforehand. These are also called as generators, right? So there len won't work. In such cases, he'll throw an error. So, but when you pass a collection like a string of characters here, you can find out how many characters are there in the string by using the len function. So the subscript operator has lots of other features. I think it's a topic for another session, hopefully, but I'll give you some basics of it, and I will continue the next session where I'll go more detailed into it. Things that you can try out. This S that I used in the previous cell, right? If I say S of 0, first scatter. But I can say S of colon 5 will extract the first 5 characters from the string. First 5 characters. Starting from 0 to 4th index. 0 to 4th index apparently is the first 5 characters. If all I want to extract the last 6 characters in a string, how would you do that? You can try this. You can say S of, some of you might say minus 1 colon minus 6. So that won't work. Remember, when you use a slicing operation, the first value that you use must be towards the left side of your sequence. The second value that you use must be towards the right side of the sequence. So you have to use minus 6 colon like this to get the last 6 characters of a string. So extract, you can say slice the first 6 characters. No, first 5 characters, sorry. First 5 characters. And last, rather than characters, I want to make it more generic. Items. The items of a string are all characters anyways. So first 5 items and last 6 items. Right? You can also get excerpt of string when you know the index and so on. You can just do S of, I can give something like, say, get me from index 10, 10th index up to 15th index. Oh, I know it's test. You start counting the string, the indices. If you start counting like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, if you could count, the test comes up 10th index. Try counting it. It comes up 10th index. So it's like 10, 11, 12, 13, 14. Actually, a space is included, I guess. 10 to 14. When I try to highlight it, you can see there's another space here. So maybe you try to say 10 to 14, it'll extract 10, 11, 12, 13. So TEST, right, in this case. So if at all you want to extract parts of a string in Python, oh, I say 14 here, you can use this kind of slicing operations. In many other languages, I know, like in Tcl, also called, some people call TCL, but it's generally pronounced as Tcl. You normally use this things like lindex, lrange, and stuff like that. You use special functions, lindex, lrange, and functions like that. In Python, no special functions are required. I think in Perl, you use substr, substring function. But in Python, it is all done by using the slice operation. So when you use a square bracket, when you pass one argument to the square bracket, you're trying to extract one item. But when you pass multiple arguments with colons inside them, or sometimes just colon and any argument, you're extracting slice of a string. And this is also a common sequence operation because it'll work not only on a string, but it'll also work on a list or a tuple. So all sequences support this feature, right? So these are called slicing, dicing operations. Once you know how to do these slicing operations quite well, I think this is a precursor to get more mastery into matrices, that multi-dimensional arrays that NumPy provides. So all these are also carried over to modules like NumPy, Pandas, and all that, right? If you plan to venture into data analytics, so it's a begin, right? It's a beginning of this. So something I should know about on how you can extract parts of a string by using this subscript operation with an item or a slice notation, right? I hope I covered all these things or the basics on the basics of string operations in this video. There's another format operator I should talk about is the percentage operator, which is sort of deprecated in the recent times for the use of dot format and f strings. Prior to f strings and the dot format method, there's a string format operator that was there, reminiscent of C programming language again. It has C-like syntax. So I'll talk about that in the next session when I cover the next level of working with strings, right? I hope you found this video useful. I hope you learned all the different ways you can create a string: single quotes, double quotes, triple quotes, B quotes, R quotes, F quote strings. So all of these. So all these are different forms of creating a string. I told you about basic operations you can perform on a string, the operators like concatenation, repetition, and the subscript operator where you can extract an item or a slice of a string. If you do find this video useful, do click the like button and do share and subscribe if you're not already subscribed to the channel. And yeah, please post in comments if you have any queries or doubts specific to this session. Right. Thank you very much. Hope to meet you in the next one.